Yeah, hello everyone. Welcome back to my channel. This is Rajendra. Today we are discussing about the stateful set in the Kubernetes. So all you know, right? We have started that Kubernetes series in Telugu, right? సో యా అందులో భాగంగా మనం ఈరోజు స్టేట్ఫుల్ సెట్ ఆబ్జెక్ట్ గురించి డిస్కస్ చేయబోతున్నాం. సో యా బ్యాక్ టు stateful set, like what is a stateful set and why we use for it, and what are the key features of stateful set. And previous video we have discussed about deployment, right? What is the difference between deployment and stateful set, what problem actually the stateful set solves. So all these kind of statements and all these kind of doubts and things will be discussed here. Okay, yeah, to be understanding this stateful set. Yeah, first one, what is stateful set? A stateful set in Kubernetes is a workload API object is used to manage stateful applications. That means stateful set is an object in the Kubernetes. It is used to maintain the state of the particular application. That means whatever the applications has a stateful or a state that need to be maintained. For example, in the database. Okay, in the database level, we need to be we need to be store the data. Okay, we need to be take that, we need to be maintain that state of the database, and also the redis application also, in order to maintain data in the redis. And also it's like it requires the stateful of the particular application. So in that scenario also we are going to use this stateful set object. Yeah, basically it is a most used one, and also most uh, like a preferable one in terms of production level application deployments. Okay, this is about the theory, guys. And then the key features. Okay, what are the what things will be there in the stateful set in terms of deployment? Stable network identity. That means whatever the network identity or what the endpoints will be created by a service, so that will be maintained in the stable. There is no endpoints creation for every time, because it is a headless service. Okay, I will tell you what is a headless service and all. And also persistent volume. So once we created the first persistent volume, every time that will be automatically mounted to the same persistent volume client. Okay. Oh, yeah. And also ordered deployments and scaling. It supports for the scaling and also the deployments. Deployments is nothing but it has, like previously we have seen that multiple types of deployment strategies, right? సో అలాగనే ఇందులో కూడా సేమ్ ఆ కైండ్ ఆఫ్ థింగ్, ఆ కైండ్ ఆఫ్ సపోర్ట్, లైక్ డిప్లాయ్మెంట్ స్ట్రాటజీస్, మల్టిపుల్ స్ట్రాటజీస్ టైప్స్ ఉంటాయి. అవన్నీ మనకి ఇక్కడ కూడా సపోర్ట్ చేస్తాయి అన్నమాట. ఓకే, బ్యాక్ టు కీ ఫీచర్స్. స్టేబుల్ పాడ్ ఐడెంటిటీ. Pod identity means there is a names. Pod will have the fixed name. Why? Because the stateful set by default nature will be create the stable or fixed name for the pod names. But in terms of deployment, that is we will see the random names. The hash code will be added to the pod names. Okay, yeah. And another one, these names do not be changed even after restart. Okay, once the name has been allocated to particular pod in the stateful set, that name won't be changed. Okay, will not be changed that name. Okay, that consistently that will be there, but in deployment that will not be the case. The every time we are restart the pod, the pod will recreate the pod, the pod name will be get changed. Okay. Yeah. Stable network identity, each pod gets a DNS host name. Each pod gets a DNS host name that I will show you like this. The host name will be like this: pod name, service name, namespace name, SVCN cluster. Like that, it is a fixed name, guys. It don't be changed at any point of time because the pod name is a consistent. The DNS won't be changed at any point of time in the stateful set. But in terms of deployment, that will be changed. Okay, that will be changed because of the pod name won't be stateful setness in the deployment. Because of that, the DNS host name will keep on changing it. So in that scenario, whatever the DNS name required applications, that applications will not be accessed via stateful set in the deployment. In the properly, it will not be accessed outside. Okay, you understand, right? Access means like whatever, for example, we have fast API app. Okay, fast fast API. Okay, in the fast API there is a requirement for database host name. Okay, and username and password. Like this, the things will be needed in the config file. Let's assume now we have been deployed the Postgres SQL with the deployment. Okay, with the deployment in the DNS. Okay, if I give DNS Postgres with some hash keyword. Okay, here I will give the Postgres with hash name. Okay, so in some time I have been restarted this one. This get changed to 1 1 like this. Then it has been impacted, right? The application has been impacted. Again, I need to be change this host name to connect the database. Okay, to rectify these kind of problems, okay, to solve this kind of problem, we have that fixed DNS by using the stateful set. You got it right? Yeah. This is one important problem, it is getting solved. That is a DNS importance where we use for the within the cluster, guys. Okay. Yeah. So with that, we can achieve the service discovery properly. Service discovery. That means whatever the service name we have, that service name we can be used for the further DNS name or host names. Okay, this is the most important one. Instead of giving the IP addresses and the port, we need to give the service name as a host. Okay, this is widely used problem statement, guys. Okay, because this is a one of the biggest advantages we are achieving by using the stateful set. Okay, yeah. Let us go next one. Persistent volume. Each pod get its own persistent volume via volume claim, right? Storage is not deleted when pod restarted. This persistent volume, that means volumes and volume claims. Okay, uh, these topics will be discussed in the coming lectures. These topics are not yet been done because it's like a huge topic. That means it has a lot of things need to be done. I will create one self-managed cluster. I will create one NFS server. Okay, I will show you that how the persistent volume will be work. Persistent volume claim classes. Okay, volumes, retain policies, all these things will be discussed in the coming lectures. It will be around 1 hour topic, guys. So until unless you just understand that there is a volumes in the volumes concept in the Kubernetes, so that Using that, we can be store some kind of data. Okay, whenever the pod gets restarted, whenever the pod gets recreated, okay, the data should not be lost. To keep that data safely, we use that persistent volumes and volume claims. Okay, you understand, right? Yeah. Now, ordered deployment and scaling. What does mean? What does mean here? Ordered deployment and scaling. By default, Kubernetes deployment supports for the scaling, right? Yeah. Here also the same scaling will be happen, but in terms of deployment, how it will be happen? Randomly, the scaling will be happen. Okay, the randomly scaling need to be happened means there is no sequence. Okay, for example, we have the three pods. Uh, we have the three pods. Sorry. For example, we have the three pods. One, two, three. The name is one XXY. Uh, one XX or something. One BBA. Two CCD. Okay, like this, we have the name. Whenever we are doing the scaling can be done in the any order. Either this one is first, this one is the first, and or this one is the first and second, third. Like that, there is no order in terms of deployment. But in stateful set, okay, stateful set, there is a order deployment. We have that whenever we are doing the scaling, first always one, two, three. Three pods will be there. Always it will go. The first one will be started until and unless the first one is a full with the traffic and the resources. Then the second one will be scaled, and then third one will be scaled. Okay, like that. Whenever the this gets deleted, the immediately it will go to one, and the second will be created, and the third will be state like this. Okay, like this, it the state will be maintained in terms of scaling. Okay, the deletion happens in the reverse order. Okay, that means the last pod, whatever the pod we have, from here it will be get deleted. First one this get deleted, then second, then third. Okay, 2 1 0 get will be deleted. This is a reverse order. Scaling this order, okay, 0 1 2, and deletion this order, left to right, right to left, like this. Yeah. Now it supports for the rolling updates also. Updates happens one pod at a time. Okay? One pod at a time. Yeah. Now the what is a stateful set versus deployment? What are the things will be there? Features. Pod identity. In the stateful set, it is a stable. Stable we just discussed, right? It's a stable, and here it is a random. We can see like whenever you keep that replica sets 3 to 4, then you can see that the names will be stable or a randomness. You need to be recreate in the multiple times. You can see the same name in the stateful set, but here it randomly it will be generate some pod name here. And volume, persistent volume, hep- ephemeral means like there is no state. Once it is get deleted, that's it. It won't be recreated, but here that will be retained. The state will be there. The state will be there, and it will data won't be lost in terms of stateful set. Okay, scaling can be done in the order, and it will be done in the parallel. Okay, here in the deployments it will be done in the parallel scaling. But whenever we have the applications, without any like a stateful set statefulness, then we use the deployments. But application that needs the stateful sets and all these kind of features, then we go for the stateful set. Okay, use cases whenever we have the databases, we use that one. Whenever we have the web apps, okay, web applications means front end applications, we use this one. Okay, yeah. And what is use of stateful set? Use it when your application needs. Okay, databases, mysql, mongodb, postgres, all these kind of applications, whenever we have, then we use it then. And one more thing, when distributed systems like a kafka, zookeeper, rabbitmq, at that time also we will going to use that stateful set. The applications with the sessions and states, at that time also we use that stateful set. Okay, yeah. And then what we have, important components. Yeah, this one, headless means, yeah, I have one diagram, I will show that one. uh, Come on, yeah, here. See, whatever the headless service is nothing but there is no endpoint will be created, it is a secure one, the outside we won't be. That means what it here is, there is a cluster. Wait guys, yeah, there is a cluster. Okay, there is a cluster, it has a master and two worker nodes. Okay, within the worker node, user coming to connect with this one, it's we call it as a traffic. Okay, directly will connect to service, right? Okay, service with the some port. Okay, some port, let us assume 8000, some port, right? Then the service will be talked to deployment, right? But in stateful set stateful set, the service will be there, service will be there, but this service will not be accessed outside because it is a headless service. This IP or endpoint won't be created, but the whatever with the label matching, the service discovery can be done. This service will be within this cluster, within the cluster. Okay, within this cluster and within the namespace, within the cluster only, within the cluster we can communicate with the service. So within the namespace communication and the pod to pod communication, we'll see in the network policies how we can be secure that communication within the namespaces and pod, pod to pod. Because whatever the database connections we have, the database connection should not be allowed in the web application server port. Okay, this only applicable or access only in the app servers, application servers only, not in the web application servers. Means front end and back end. Only back end can be access the what database. Front end should not be access the database. In this case, we use the network policies that we'll discuss in the future lectures. Okay, now you understand, right? What is a headless service and all? Yeah. Back to here. This is how like a headless service, all the pods will be there in this headless service directly communicate with the stateful set in the pod 1 and pod 0. Then these pods will be communicated with the persistent volume clients and persistent volumes within the node 1 and node 2. Okay, like that the communication will be established for the stateful set. Then we'll see like there is another term we have guys. See the deployment. In the deployment, as we discussed, the pod name will be random. But in stateful set, the pod name will not be random. Okay, it will be sequential order. And next, what we have kubectl. Whenever we apply, we hit that kubectl apply command, then the request directly will go to API server. Okay, that API server will validate the stateful set etcd. Okay, validate authentication or back. This all things will be discussed later. Okay, uh, assume that this validation is done, it is allowed, then the stateful set configuration data will be stored in the etcd. Okay, previous video I showed, right, whenever we are doing some editing the deployment configuration or replica set configuration, at that time I see that complete configuration key value pairs. Okay, that configuration is storing in the etcd server itself. Okay, this etcd, the default all the servers will be running in the master node, guys. This complete architecture level explanation I have been done in the day one of the cluster setup and cluster details videos. If you have any doubts, if you haven't done that clear, you don't have any clarity on the master nodes and services, then please go and watch that video. Okay, yeah. And then there is a stateful set controller, guys. That controller, what that controller will do here is, it will be whatever the pod we get created. Okay, that pod name is a unique pod name will be created. Okay, it is a ordered creation. And then whatever the pvc get attached to that one, that will be wait, the pod will be wait until the volume get climbed. Okay, unless if it is not climbed properly, then it will go into the pending state. Okay, when you see that describe the get pods. Okay, kubectl get pods hyphen n and namespace dev, then you can see that is in a pending state, because the binding is not happened with the pvc and pv. Okay, this will discuss in the later. Assume that like this, the sequential, the pod 1 pod 2, the communication will be established, the connection will be established between pvc and stateful set is ordered way. First one is this one, and then this one, then this one, like this. Okay, and yeah, what is a headless service? Headless service, it doesn't have the any IP and port configuration level. It supports for the service discovery concept in the Kubernetes. By using the service name itself, we can be configured that in the to access that in the other applications. Okay, yeah, this one. See, this all are the stateful set. These all are the persistent volumes in the node level. So the pod will be connected to the persistent volume 0, climb 0 1. That will be the climb will be connected to the first system volume. Because of this, the state of the every time the pod one will get connected to this one only, the node one, this one. Because of this, the whatever the state, the data inconsistency, the problems won't be occurred because of these kind of statements. Okay, so here the problem. Okay, this will discuss in the later, guys, when we are go in depth, when we discuss in the PVCs. Okay, that's it. That's all about the theory for the stateful sets. We'll go into manifest files. Write a manifest file. Actually, I have written one manifest file for the project that I will show you. Uh, uh, here only. we have the Postgres, right? Dev Postgres. Till here only we have other things also, but don't be see those things. You will get confused. Uh, where I should keep this one here, I will keep. I will explain the manifesto file of the stateful set. Okay. Actually, previously I have done one project, guys. That the same thing I will explain here. Yeah, back to here. You can see it, right? Else, yeah. Um, Here, as usual, the API server, API version, and the kind, stateful set, and the metadata. Here, I have used the namespace called dev. This is the stateful set name. I defined it. Then the replicas. How many replicas I have given here? The service name is used for the headless service. It is most important, guys. It will be going forward. This is a DNS name or service discovery host name. Host name. Okay. And the replicas, how many I have given? Only one replica I have given. And the match label is Postgres. And then template label, the same. The deployment configuration, how it will be this. Same. The template, pod template, what I have given, Postgres same. The specifications in the container Postgres, and the post container name is a Postgres 15. Then the what is the target port container port here? 5432, because a default the Postgres port is a 5432, right? The same thing I'm using. Forget about all these things. This is a secret and all, volumes and all. Okay. And forget about this resources also, resource and limit also we'll discuss in the later point of time. This one also we'll see in the later point of time. Yeah, here the service. Okay, the service create a headless service. What we use here is the whatever the cluster IP we are giving. Here we are giving it as a none. If we are mentioning this as a none, then it creates as a headless service. Okay, headless service means here from the outside there is no calls. 172.0.192. Okay, for example, if it is a node port, node IP or a cluster IP, this kind of IP won't be assigned for the headless services. Okay, here we have only the service name. What is the service name? Postgres, right? The Postgres will be there. We can use 5432 like this. We can access in the applications. Remaining all same, guys, like selectors, whatever the label you have given here, the same thing we need to be mentioned, that is the selector. And the ports, the target port will be this one. Okay, in the above I have mentioned, right, that one. And the port, whatever the service by default service port will be this one. And the name and the way the namespace I'm running it in the dev environment. Okay, yeah, this is about the manifesto file explanation. Okay, and now we'll see some little bit practicals around this one. Okay, kubectl get all. If I have any previous kubectl, if I have any previous applications are running in the cluster, then I will delete those things. Yeah, one of the services running here, I will get deleted. Previously, what I have used here is the get pod. We'll see like get pod. Yeah, there is no ns, not ns SVC. Yeah, one service is getting okay, running here. I will delete this one. Kubectl delete delete svc. Okay, it got deleted now. Now I will go and kubectl apply hyphen f dev postgres. Okay, create a dev namespace now. Kubectl create a namespace dev. It get created. Okay, kubectl get all hyphen n dev. See, here the container is getting created, and we have the stateful set name. Okay, stateful set name, and it get ready. No, it's not ready. When we are seeing 0 by 1 means it is not ready. Okay, it is not ready. That means it is not get started at. Just wait for some time. It get created. Okay, until unless we go and check with the nodes what will be the next. We created this one and we are checking the stateful set. Okay, to get the stateful set we can use this command also, guys. uh, Make sure we need to give this namespace where it is running. Still it is not running. We'll see that, and then we can describe the stateful set with the name. uh, what I will do here is I will describe the stateful set. Describe because it is taking more time here. Postgres. Yeah, what exactly it is telling here is okay. The pod Postgres 0 is stateful set. Go right. Postgres is successful. Then the configuration of and then NFS mount. Okay, it's trying to connect to this server. Okay, that is the reason it is not getting created. Okay, because this is a cloud server, guys. Previously, I have tested with some other things. Okay, I will remove that one. Okay, delete. Dev Postgres. The Dev Postgres NFS server. Okay, what I will do here is I will be editing the VS Code because there is something I need to be do in the VS Code, the file itself. Sorry, guys. Just wait. Please wait. It has some problem actually. Mm, it has a problem, so that I need to be done it. Just wait. Just wait. Don't say. Come on. What is this? Mm, okay. Okay. Um, come on, come on, come on. Sure. Okay, okay. CPU is taking more CPU cache is getting. That is the reason actually. Oh wait, wait, wait. Sorry guys, my system a little bit slow. Okay, okay. Yeah, sorry guys. My system got stuck in some point of time. Okay, back to here. The problem here is there is a yeah. Okay, then this will discuss in the guys because the system is stuck now. Okay, I will show you that what is the problem and all. Okay, yeah, and after this, what we have more practicals we need to be show. Okay, I need to be show. Yeah, definitely I will show that part also. So why these things will be happening. Yeah, that's it, guys. So we'll see the practicals, stateful set practicals in the next video. At least it will go 10 minutes. Okay, thank you.